Event detection is a prerequisite for many eye tracking analyses, yet existing solutions are often limited, requiring coding experience, relying on closed source vendor tools, focusing on narrow paradigms such as reading, or supporting only a single recording setup. Therefore, we present OpenGazeLab, an open source browser based toolkit that unifies event extraction, parameter configuration, and data inspection for both stationary and head mounted eye tracking. Let's start with the stationary setup. First, the user can upload raw gaze data in CSV format and can also drop in a background stimulus image so the gaze positions align perfectly with the on-screen content. Next, using the configuration panel, they can define the core processing behavior. They can pick an algorithm, either IDT or IVT, and adjust settings like the display plot origin, resolution, sampling rate, minimum fixation duration, detection threshold, and merge threshold. They can also toggle the adaptive thresholding and automated optimization features using simple checkboxes. Once they're set, they click Process Gaze Data. After processing, the interface provides a concise statistical summary. It shows the total gaze points, breaking down how many are fixations, saccades, out-of-range points, or invalid naians. It also displays the number of fixation centers and optimal threshold used. Users can also download the fully processed event list as a CSV file for downstream analysis. Furthermore, OpenGazeLab provides a timeline slider and synchronized video playback that overlay gaze and detected events on stimulus images or scene videos for rapid visual inspection. Now, let's look at head-mounted eye trackers. The workflow is very similar. Users upload the raw gaze data, the ground truth labels, a scene video for background mapping, and set the detection parameters. Then, the detection results will list the total gaze points, fixations, saccades, optimal threshold, and the video duration. Additionally, it provides an F1 score, allowing you to easily compare the toolkit's predictions against the provided ground truth data. For visual inspection, it provides synchronized video playback that overlays real-time gaze data directly onto the scene camera recording. Users can independently toggle 6 visual layers over the video frame. Gaze point, the current gaze position drawn as a glowing color-coded dot, green for fixation, red for saccade. Gaze trail, a color-coded path showing the recent history of where the gaze has been. Fixation centers, numbered circles that scale proportionally with fixation duration. Scan path, a dashed line connecting recent fixation centers to show the order of visual attention. Flow arrow, a directional arrow indicating real-time head motion magnitude and direction derived from optical flow data. GT comparison, a per-sample match or mismatch indicator against your ground truth labels. Below the video, a clickable event timeline lets you navigate the recording. It's color-coded for quick reference, showing predicted fixations in green and saccades in red on top, and ground truth events below in yellow and purple. For further details, please refer to our paper,